Uh, Good morning to everyone. Thanks for joining the Domain Expert channel. Today, we're going to design and implement the three-tier network architecture to manage and support the infrastructure. Here as a demo, we're going to provision the small office with network infrastructure with two VLANs. Okay, let's get started. So I have picked two VLANs. The VLAN number one is end user with VLAN ID is 100, and the second VLAN is server VLAN, which has the ID 200. Okay, now let's go back to the topology. As it here we have the two VLANs, VLAN number 100, which has assigned with the CIDR range, which is 172.20.100.0/24, and the VLAN number 200, which is assigned to the server VLAN and has the CIDR block 172.20.200.0/24. Okay, my requirement here is I want to communicate. The PC1 want to communicate the server. Okay, so in order to accomplish this task, we're going to perform the following steps. The first step is assign the CIDR block for both the VLANs 100 and 200. Okay, in the core switches, we are going to assign it, and we're going to create the VLAN in the access switch, and we need to pass the VLAN where the PC and servers are connected, and make the interfaces F01, FA0/1 and FA0/2 to the trunk port, as this is uplink connected to the core switches. Okay, if you see here, we are passing the VLAN number 100 on the interface FA0/24 and VLAN number 200 and FA0/23 interface. And in similar fashion, we are also making this interface FA0/1 and FA0/3 as a trunk port, because we want to carry multiple VLANs. In similar fashion, we are also making this interface FA0/2 or FA0/4 as a trunk port. Okay, so let's get started. My requirement here is I want the PC1 want to communicate with the server, and the PC IP address is 172.20.100.0, 100.1, 100.10, and the server IP address is 172.20.200.10. Let's check from the IP config itself, command itself. Okay, the IP address which has assigned to the PC1 is 172.20.100.10 as per our network flow. And let's go back to the server. Okay, so let's check the IP address of that as well. Okay, the address of the server is 172.20.200.10. Now let's test it from the PC1. I'm going to test it 172.20.200.10. Now I'm unable to send. I'm unable to get any response from the server. Right, I'm getting the request time. Right, now let's clear this out and let's start implementing the steps. The first one is we need to create VLANs, VLAN 100 and VLAN 200 in the access switch. So for that, I'll assign the hostname access switch. Okay, here I'm going to create the VLANs, VLAN 100, name as end user, and VLAN number 200, the name as server VLAN. Now we need to pass the VLAN. Okay, and then we need to pass the VLAN 100 on FA0/20. So for that, I will be going to the interface FA0/24. Now I'm passing the command switch mode access, switch mode access VLAN. I'm passing the VLAN 100. In the other direction, I have one more interface which is directly connected to the server. The interface is fast Ethernet 0/23. I'm passing the VLAN switch mode access VLAN 200. Okay. So now one side we have completed, we have passed the VLAN. The other side we have to make these two interfaces as a trunk port because we want to carry multiple VLANs. For that, I'll be going to the interface 0 by 1, converting this interface to trunk. Okay. And on the other side, I have one more interface, FA 0 by 2, which will converting to trunk. So this from the access side level, we have completed all the steps. Okay. Now let's go back to the core switch. So let's start configuring the host name, host name C1, core 1. Okay. Here we have to create the SVAs. Okay. The VLAN, the SVA VLAN for 100 is 172.20.100.100 and SVA VLAN 200 is 172.200. Okay. This is the topology which we're going to design. So for that, I'm going to create SVS VLAN 100 in core 1. Interface VLAN 100, IP address 172.20.100.1. And send the supplement must to 5.2.0. No shut. And making this as a standby. We're using the HSRP IP 172.20.100.100. Priority 150 because I want to make the core 1 as a primary and standby preempt. Okay, in similar fashion, let's go back to the interface. We'll add 200. Okay, now and create assign the IP address 172.20.200.1 address. One shot and standby IP 172.20.200.100. Want to keep 100 as 100 at the both ends. Okay, let's change this to 100 as well to avoid the confusions. 100 standby priority 150 standby preempt. Now this is done. So standby. Okay. Now let's come back to the core switch 2 and let's make the configurations. C2. Let's create the SPS for VLAN 100. IP address 100.2.5.2.2.0. No shut. Standby 172.20.100.100. Standby IP. Now let's create SVA for VLAN 200. IP address 172.20.200.2.2.2.0. Shut. Standby IP 172.20.100. Now let's try to ping this. Ping 172.20.100. Speaking 200.100. That's good. Now in the similar fashion, we have two more interface which is directly connected the core 1 to core 2. We have to convert this interface as a trunk port as well. Okay, so interface FA 0 by 1 port no trunk trunk encapsulation. And I have one more interface FA0x2, 0x2, for mode trunk, switch for trunk encapsulation. In the port 2 side, I completed, and back to the core one. Configuring interface FA0x1. Okay. Switch mode trunk, switch port trunk encapsulation. And I have one more interface FA0x2, 0x3 interface, particularly 0x3. Mode trunk encapsulation. Trunk encapsulation. Okay. So this is good. Now let's try to ping whether we're able to reach the server 1 from PC 1. Let's try to ping the same. I think definitely we should get some first request would be definitely after it takes some time to get the resolution. Yeah, now we're able to receive some response, right? This looks good. Now my requirement here, one more requirement here is I have some IP address. Okay, so that is show IP interface brief. Okay, so 8.8.8 is the Google DNS. From my local PC, I want to use the Google DNS. So let me try to ping this IP address. Ping 8.8.8.8. Let's see destination host unreachable, right? So meaning we don't have routes or we don't have any access to reach the internet. So for that we're going to deploy or provision the network implementations. Now the first thing is we're going to enable the routing. Okay, so in these cases I want to use OSPF between core 1, core 2 and router 1, and from the edge router to the service provider I'm going to use the BGP, okay, to learn the external routes. So I'm going to use the routing protocol called OSPF router OSPF 1. And before that I want to assign the IP address for the both core 1 and the router as well. Okay, so interface Ethernet 0x1. I want to use the IP address call. For core 1, I want to assign the IP address 192.168.100.1. For core 2, 192.168.200.1. And core 1 to edge router, meaning this interface on the router side, I'm going to assign 192.168.100.2. And core 2 to edge router, I mean this interface giga 0x2, I'm going to assign the IP address 192.160.200.2. Okay, so here I'm using the OSPF and BGP, and here we're using external IP address 200.200.200.0/24 to reach the external network. I mean to reach the Google DNS from the local PC. Okay, so this is the requirement. Let's proceed to assign the IP address on the Giga Internet 0x1 IP address. So when I try to type IP address, I'm not getting. So I need to convert this port to no switch port. Okay, I'm converting this interface as L3 interface. Now I'm able to get the IP address. Yes, 168.100.1 to 5.0. No shut. Okay, and even I'm going to assign the IP address in the core 2 interface Giga Ethernet 0x1 IP address convert to A3 IP address 192.168.168 1.1.5.2.5.0. No shut. Okay, no signal. Now we'll come to the router. We'll configure the IP address to the both interface. Name, customer is router CE, and I'm going to the interface Ethernet 0x1 because this is directly connected to the core switch, right? So here I'm going to assign the IP address 192.168.168.2.0. Let's try to ping 192.168.100.1, which is the core one interface. So I'm able to reach, right? Now come back to the interface, Giga Ethernet 0x2, send the IP address 192.168.200.2 and submit mask. Now try to ping 192.168.200.1. I'm able to reach, right? Now I'm going to use the routing protocol called IGP, routing protocol called OSPF. Okay, so I'll come to the core customized router. I'm going to use a router OSPF1 and network. Go to today's 192.168.168.100.0 and wildcard mask 0.0.0.0.25. I'm going to use area 0. The simple fashion I'm going to enter the network called 200. Okay, so this is complete. Now come back to the core one. Let's enable the OSPF1 network. Advertise 192.168.100.0 subnet mask area 0 and also advertise the VLAN number VLAN 100 VLAN 200 20.100.0 and 200.0. Okay, now it should come up. To 168.0 area 0, right? Yeah, I think now it's came up 200.2. Show IP route. Now configure the OSPF in the code. Router OSPF 1 network 192.168.100.0 by area 0 network 200 and also advertising the local VLAN 100 and VLAN 200 172.20.100.0. So 70.20.100.0. I think I need to add JVRG. Okay, now I'm going to address VLAN 200 as well. Now show IP OSPF neighbors. Right? Extra step, it might take some time to get it. Right, if you see, now everything is, the state is full and clear. The similar fashion, okay, now come back to the core one and check show IP OSPF neighbor. See, I think I am able to see the neighbor relationship between the core one and the router, right? This looks good. Now try to ping it. Still I'm unable to reach the 8.8, right? So So if you want to reach the external network, definitely either we have to use the static routing or we have to use the BGP. In my case, I want to use the BGP. Okay. So this router, we have the AS number as 100. And on the other side, service provider is often, they have their own service provider, AS number called 200. Now I'm going to use router BGP 100. And I'm going to address, I'm going to establish the neighbor relationship between the uh, remote side, that is 200.200.200.200, and remote yes 200, because you see here I have the IP address 200.200.200 is my IP address, which is assigned to the Giga Ethernet 0 by 0. Okay. Now address the network 200.200.200.0 mask 255.255.255.0. Now let's see, BGP should come up running. Show IP BGP summary. So IP route, not receiving any route, meaning BGP is not established. Summary. Let's come back to this opposite side. Let's check. We have show IP BGP summary. Clear IP BGP. Okay, now let's see. Summary. Stage prefix received. Okay, this looks good. Show IP BGP. Show IP route. Let's check why we're not receiving the routes. I mean 8.8.8 to my customer is router. I think this interface still is not up and running, right? Let's try to ping the IP address 200.200.200.200. Looks like the interface was not up and running. What I will do? So first thing is BGP required the reachability, right? To establish the neighbor relationship with other peers. So IP interface brief. Oh, okay, this is the problem. If you see here, I have not assigned the IP address to the Giga Ethernet 0 by 0. Now let me assign that IP interface Giga Ethernet 0 by 0 IP address 200.200.200.200.100 No shit. Now I think if you see now the BGP should come up. Show IP BGP summary. Ah, there it is. Now I think I received messages. I sent the messages. Okay, this meaning two-way communication is happening. And even now, let's see the routes. Show IP route. The customer is route. There it is. Now I'm able to receive the routes from the service provider Airtel. Okay, so this is my service provider. Okay, I'm just here mentioning as Airtel. Airtel has IP show IP interface brief. Here for testing cases, I just created the two loopbacks 8.8.8, meaning it's a DNS, and 4.4.4.4. Just I'm trying to ping from a local machine. Okay, now I'm able to receive the routes in the customized route. Now let's try to ping it. Now let's see what is happening. Still, I'm unable to reach the destination. Now, what will be the reason is let's try to see whether we are receiving the same routes in the core switch. So IP route. Okay, so this is the problem here. I'm able to receive 8.8.8 route in my customer edge router, but I'm not receiving the core core switches. Either this can be fixed in two ways, or the one way which I'm explaining here is redistribution. Okay, so what I'll do, I'll come to the here, the core edge router. We'll come to the router OSPF1 and redistribute BGP into OSPF. Redistribute BGP 100 subnets. Now let's come to the core switch. Let's try to check IP route. There it is. Now I'm able to see 4.4 route and 8.8.8 as a E2 type. Okay, so that these two routes we're receiving from the OSPF. Now let's try to ping it. This time I'm able to send some traffic. Okay, but I'm not getting any response. Instead of destination not reachable, but at least this time, I'm getting request timed out. Okay, now let's try to find out what is the issue here, how to reach the destination. Okay. So what I will first, for example, I'll just enable the debug IP packets. Okay, now let's try to ping here. Let's see what is happening. There is one concept which is missing here. Okay, so if you see this packet, okay, the source here is 172.20.100.10, meaning this PSC itself is generating the packet and it is sending directly to the service provider. Remember, private IP address will not be routable on the internet. It should be routable only with the help of public IP address. So to achieve this task, we have to use the concept called NAT. Okay, let's enable NAT in the customized router. So let's exit. So IP interface. Let's brief and let's enable NAT interface. 0 by 0 IP NAT outside. Click exit. One IP NAT inside. And I'm going to move to the second interface, converting this to IP NAT inside. Okay, now let's try to configure the NAT, IP NAT, IP NAT inside source. Okay, here I'm just using the list or as local LAN. Okay, an interface overload interface. You get the net 0 by 0. This is my external interface, which is directly pointed to the service provider, and I'm using the keyword called overload to perform the that operation. Okay, now let's exit and let's try to create the access list. IP access list extended local LAN permit ICMP, just enable ICMP for our use case. Source address. Okay, I'm just writing 172.20.100.0. Wildcard mask 0.0.025. Any, that's it. And add the VLAN number 200 as well. That's it. Now let's try to test it. There it is. Now I'm able to ping 8.8.8 from my local machine, meaning I'm able to reach the route which is hosted in the internet. Okay, that's what we get. The similar fashion, even I can able to reach from the server as well. Ping 8.8. Ping 8.8.8.8. I'm getting some response. Okay. Since we configured the HSRP, let's do some failover test. Okay, so currently I made this core one as a primary and core switch to as a secondary. Let's try to bring this interface down. Let's try to failover this interface to secondary. Let's failover the traffic to the secondary. Okay, now what I'll do, I'll navigate to the switch, access switch itself. I'll shut down the interface. FA 0 by 1. Okay. This is F0 by 1 is this interface. This all the traffic now is moving to a core switch. Now let's try to disable this, shut down this interface. Now let's try to ping it. My requirement instead of sending the traffic to the core one, now require my PC has to send the request to the switch. Switch has to forward the request to the core 2, and the core 2 has to forward the request to the edge router from edge router to the ISP. Let's try to verify it. Okay, let's try to ping it. So definitely, probably one or two requests will get the request timeout. Then because we're using HSRP, it will take some time to fail over. Okay, let's wait for a few minutes. Let's try one more second. Yeah, there it is. After 4 request timeouts, then we are able to send the traffic to the core 2. Okay, so that's it, guys. I hope you understood the concept. Yeah, thank you all for watching. Thank you.